Good evening, ladies and gentlemen. As it was introduced, my name is Felix, and I'm supported by Mr. Arun Rajaratnam, who is my kind of guru on this corrosion subject. So we are thankful for inviting us for this session. And as it is stated, the question time topic is asset protection and design durability in corrosion control of metal structures. It's a very long subject, and I wish to thank Engineer K.J. Savan, President, Engineer Vice President, and the Honorable Committee members who supported us. And we send our greetings and felicitations from our board of directors. And today we want to share the knowledge on the corrosion. What do you like to have? Okay, to understand corrosion, I think everybody knows corrosion, and predict costs and plan mitigate losses. That's the anybody's requirement. When we say mitigate losses, we talk about the degree of loss of metal. So we have some steel plate corrodes if the weight goes down. So this is as shown the subverse on the BMW thermal power station. So it's huge steel structures. It was built in 1998. 15 years after only it was repainted. So that's the durability. We'll be talking about durability now. So that's what you need. And as you all structural engineers are trained to understand or predict and calculate the stability, strength and rigidity. That's what the Wikipedia will be. So we want to show that when you really understand and can predict and calculate. So what you do from morning to evening is design. So when you say design, you go by principles and standards. So there's a nice word called durability. When I look at Oxford, it's the ability to withstand wear, pressure and damage. Very simple. If it can withstand wear, withstand the pressure and the damage, we are through. So generally we know that a lot of structural engineers are civil engineering professionals, but we work on the metal structures. So we know that the steel is, lead time for steel is longer, but the erection time is shorter when you compare the concrete. Of course there is a disadvantage where if there's a high-rise building and if the fire catches 450 degrees centigrade building fire, it will collapse. So we saw in this restoration of Colombo buildings where the British were constructed, they have put the steel H-beams and covered with some calcium kind of this chicken mesh. So they have thought of this passive fire protection long time ago. Now we have these intermittent coatings to replace those passive fire protection needs. So first I will start with. Now there's a big issue, like when people are salesmen, when people they come to ask me, what's your liter cost? So sometimes I get angry also because it's a pain shock question. Liter guard here. But these Americans, they have in 1999, 2001, they did a weather forecast because America always suffer with this disasters, tornadoes and things. So the US Federal Highway Administration, NACE, and the CC Technologies joined together and did a 2-year research. And they found out, and they claimed that the corrosion cost is 3% of the national GDP. So that's the, like cost-wise, we have something to hold on because we don't know what the cost. So this is from the American market. You see that gas distribution, drinking water has the most corrosion cost. Then vehicles, defense, like that, they have different sectors. And in Australia, it is the GDP 2008 was 2,179 billion. So going by the 3% is at 70 billion. So that's your figure for the corrosion. So it's a big market. But only thing, people don't think big in this corrosion. They wait until it collapses. So this is actually a well, the oil drilling. So there are a lot of classification societies like the Lloyd's, the DNB, they do a lot of research on that. So they have given some figures here, what kind of costs involved. So in 2016, most recent one, still they believe the estimate global cost of corrosion to be 2.5 trillion, equal to roughly 3.4% of the GDP. So this is Sri Lanka. Sri Lanka is 81 billion US dollars. If you go by that, there is a corrosion cost of, I don't know, there's a lot of zeros in this. So it's a huge amount. So today's topic, we learned that we try to get into that stability, strength and rigidity that's your need. So we'll talk about corrosion durability, some relevant standards, some definitions of the corrosion. Then I think I participated in this last seminar where Professor Priyanka has told about carbonation and chloride-induced corrosion. We'll talk a little further on the steel side and different types of rust grades. So corrosion, if durability is the wear, pressure and damage, the other side of the durability is the corrosion, the failure to withstand wear, pressure and damage. And it leads to instability, which means your rigidity and it get out of shape and strength will weaken. So corrosion and your scope will always fight each other. So it's important. This photograph is a photograph of a very new hotel, just 1 year in Colombo City. The cooling water section, the tower, the structure is corroded. So they have invested a lot of money and they want to replace this steel now within 1 year. So this is kind of a thing, there's no commitment on the corrosion side when it was designed. So this is a corroded door just on the rooftop. And this is the Southern Highway. There were some LPG gas lines. Just now 6 years, everything is corroded. Now they are thinking whether to replace or repaint. So this is only 6 years. So now when we look at our requirements, your job is understand but you can calculate. So as structural engineers, you are supposed to do that. But the issue is that the main contract, the next step, and the subcontract, the next step, do they understand, do they predict, do they calculate? So I think there's a gap knowledge gap in the corrosion, which leads to some problems. So these are, we discussed and found out some of the major problems faced in Sri Lanka. We call it mistake, it's not a mistake, it's a challenge. Now, a lot of overseas contractors come, local contractors come, big companies like Dockyard or sometimes. But the issue is the site people, do they know the standard? The top management knows this, they are committed for that. But the site, when you go down the line, the standard is not known to them. The second one is, now there is a total design for the building and the anti-corrosion. So now, you want to know whether they are capable of developing this part. If you don't develop this part, then it won't integrate with the major one. And the other one is like now in coating the corrosion, we do this marine painting or particle galvanizing or whatever. So there are basic test equipment. So if you don't test, you will not achieve because you are not done it according to the rules. So now Dockyard, I know we have these film thickness gauges, these durability gauges, we check those. But there are other companies, I'm not downgrading, they don't know what this equipment is. So unless you all, in your BOQ specify, all contractors should come with this equipment, finally you will be facing some trouble. So now for instance, I think you are very well aware, the parameters for coating application. Now if you ask the painter, nobody knows this. But when you look at, if you speak to Sir Prasad with the NACE experience, he will tell you 3 parameters. The one is, you cannot apply paint if the steel temperature is more than 55 degrees centigrade. You cannot paint if the relative humidity is above 85%. You cannot paint The steel temperature
When using the Elcometer 456
lower than
dry film
3
thickness
degrees
gauge to measure
of the
the
dew
thickness
point.
of a coating on smooth
Now our science
substrate,
people
a
don't know
quick
dew
and
point
simple
also.
method of
They
calibrating
don't know
the
relative
gauge is the
humidity.
zero or single
But
point
they take over
calibration
big
method.
jobs.
To undertake
Now I
a
see
zero
that in the world
calibration,
is
you
a lot
will
of
need
Chinese people are working.
an Elcometer 456 DFT gauge and a probe if
So now
using a
these are
separate
parameters
gauge,
that follow them.
and ideally
Now, for
an
instance,
uncoated
this
sample
is
of the
what we
substrate
showed
you'll be
you
measuring on.
Now this is little
An
gadget.
uncoated sample will always result in a more accurate calibration and should be done whenever possible. However, if one is not available, a smooth Elcometer zero plate, either ferrous or non-ferrous depending on your sample's material, can be used. Don't forget, if you're working on both ferrous and non-ferrous materials, then you should calibrate on samples of both.
11.3 dew point.
The Elcometer
And
456 is an intelligent gauge, so once the gauge has been set up for the zero calibration method, it will guide you through the calibration process one step at a time.
The RH is less than
Select the zero
85%,
calibration
you can
method,
paint.
press the CAL
The
soft
steel
key,
temperature
highlight the
is
CAL method
20
using the
degrees
down soft keys,
and the T
and press the
delta
select
is
soft key.
11, more than 3.
Highlight and select
So without
0, followed
Keeping
by
a
the back
product
soft
like this, the equipment measuring
key.
the
Zero
equipment like
calibration
this,
icon will now be
people start applying
displayed
paint
with the
without
CAL menu
following the
item.
parameters.
To calibrate the
It's
Elcometer
a
456,
dangerous,
simply select the
because there are
Calibrate
many
menu item and follow the on-screen
And
prompts.
also
The Elcometer
you will specify
456
your
will ask you to
UV,
place the
okay,
probe onto the
apply
uncoated
300
substrate,
microns or
0
200
microns,
microns. But how do you know
Hold
that
like
it's
a
200
fan.
microns?
and
You
place
have to
them
have it.
evenly at a 90-degree
You
angle to the
at the end of the
surface.
session, you just
The
keep on
Elcometer
speed, paint
456
plate,
will
and
adjust
you
the
measure
calibration
it.
automatically.
So if you
When
don't
you're ready,
monitor
you
it,
start measuring.
you'll have failures.
For more
So,
accurate method
Sri
of
Lankan
calibrating the
contractors
Elcometer
of
456 on smooth
fabrication,
substrates,
painting,
you can always select
they
the
have
smooth
this,
calibration
equipment.
method.
Now say you
Click
have
the link on the
Sandblast.
screen to see how it's done.
This SA
Or,
2.5
for more
is the
information and training on the
the
Elcometer
standard
456
for
coating
Sandblast.
thickness gauge,
Now,
click on
after
any one of the
Sandblast, you
titles
have
on
a
screen.
R reset. Like you look at a Docker, there's a thing called a Sigma Power 280 product data sheet. The second page, you find a thing called the R reset, 40 to 70 microns. Which means you take a flat steel plate, you sandblast it, you make your steel a
For more
profile.
information and
Average
training on the
blast
Elcometer
profile.
456 coating
On
thickness
the
gauge,
profile only
or
your
other
paint will
Elcometer
be
products,
applied.
visit our
But
website.
if you can't measure the profile, then it will fail. The product data sheet, manufacturer's data sheet will tell you that. Sigma Cow 280, other side, second page. Sigma Cow 280. So the manufacturer tells you this RZ. But our people don't know what RZ is. So it's a very traffic situation sometimes. And after paint is applied, there are so many results. So there are little gadgets like this, a sponge test or like a steel wire test. You just keep it on the painted surface.
Whether you're
it
coating
beeps
a pipe
if
pipe
there's a
or
miss.
another coat.
So without
Balance
checking with the
on a
miss,
flat roof.
after 6 months,
Apply
the
the
corrosion will
corrosion
take place at that miss.
There are many
And you
parameters
can't
that must be monitored or controlled
pay the
to
retention
ensure a
to
coating
your
performs
contractor.
over the
Because
lifetime
there's
of the
corrosion.
product. One of these
But if
parameters is
it,
how the coating is
if
covered
the
the surface.
detection has been
And
done
if there are any flaws
at
in
the
the
time of
coating,
handing over,
penetrate
and if there are no
corrosion.
pinholes, then
Corrosion
you won't have this
is caused
retention
by
problem at
the
6 months.
steel substrate
So this
and
happened,
oxygen,
actually
or
we had
contaminants
some
such as
experience
water
with
in
this
its cellular
Yukon
process.
railway project.
The coating is
We
there to
took
protect
these
the steel
machines and we
from
measured
oxygen
it.
and
Lot
contaminants.
of qualities.
A flaw in the coating
So
can make
CCB
the
says no,
substrate
we are not paying you.
or in some
RLA says
cases
no.
completely exposed.
Finally they upgraded and they
In the
wanted us to
protective
test
and
and tell
industrial
that there's no
chemical
holidays.
industry, there are a number of
So you
things
need
to
this
be aware of.
little measuring devices. Without this corrosion control is not going to be real.
Where the coating moves under gravity.
As
typically
you all are
caused by
mostly
overcoating
familiar with the
in
concrete,
thin areas of
and
cover,
this is a very familiar to the professor. Before
System.
the corrosion
where the coating
and after the
doesn't
corrosion.
stick to the
So
substrate
this is the,
properly due to surface contaminants,
mental agony of a
heat,
structural
oil,
engineer.
leading to
If
surface
the
breaks in
steel
the
bar,
coating
rebar,
which expose the substrate.
load up, corrode,
Cratering,
and then a
where
piece
air
falls
and
off.
silicon bubbles are released from the
All your
surface when the
that
coating is
rigidity and everything goes
cured,
for 6.
and the coating doesn't
So you
float
can't have these
or
cracks coming up.
leaving small craters
we
that
talk
will
why
not
these cracks
cover the
happen.
substrate.
In a rational way.
Pinholes, similar to
So,
cratering,
now,
air or gas bubbles
at the last seminar, you were always talking about concrete,
the coating doesn't
steel,
cover.
corrosion.
Unlike cratering,
Now
pinholes
you are
will
like the
always
reinforced
the
concrete
substrate, leaving
department.
it fully
Now
exposed.
we are in the pre-engineered steel work
Overcoating.
department.
If too much
We are
coating is applied,
meeting
the top
somewhere,
dries out quicker
each
than
other.
the bottom,
So
creating a
this is,
skin
I thought
that
we
then
thought we will
shrinks
make
as the
this
coating
connection.
beneath it dries out,
How your
cracking the skin.
civil
And
engineering,
undercoating.
structural engineering
If the
part
coating is too
will
thin,
connect to
heat
the
and
steel
the surface
fabrication
profile are left uncovered or
connection.
thinly coated, which leads to rust spots,
Coming back,
also known as rust
cracks
marks.
happen, stability goes
These
off, strength
flaws are
goes
referred
off,
to as
rigidity goes
holidays,
off.
discontinuities, or
Now,
pinholes in
Professor
the coating.
Grant there showed us the
They are
Eurocode 2.
often very
In the
small
first
and
day
invisible to the
I
naked
came
eye.
across this
This is
Eurocode
called
2
detectors,
because I am a
isn't
steel
it?
man, not a concrete
There are
man.
essentially
So
three
Eurocode
core
2,
detections.
I thought is a different world. We are in a different world. But when we looked at it,
The low
looks
voltage
very
pinhole,
familiar.
or wet sponge
I think
technique,
one
such
common
as
guy
the
has
Kilometer 270,
put three
is for
standards,
testing
four standards,
insulating
given to
coatings less than
different
500
people, and we don't
microns thick
relate to
on
each other.
conductive
And
substrates.
it talks out
It is ideal for
of the
powder
aggressivity
coatings
of the
and other
environment.
applications we
Very
don't wish to
important.
damage the
And the
coating.
specified service
However,
line
this method
durability.
only detects pinholes.
So what you want to do is
Pinholes are
sufficient cover
important to
thickness,
detect because they are small
sufficient permeability of the
all the
concrete.
way to the
Then
substrate.
my friend says don't put
Acts
sufficient,
like
they equal
drawing
impermeable.
moisture drops
I
down
don't
to the
think there's
skin
any permeable concrete in the
reaction,
world.
where liquid
So
can
sufficiently
flow through narrow
permeable is
spaces
okay.
without
So
gravity,
in combination with the
accelerating
coating,
the
so
process
that's
of
what you
corrosion.
want to do generally.
The wet sponge
So,
method of detecting pinholes,
Coming back to this
which is a little
corrosion,
bit of a misnomer,
this is
as
a
dispersion
definition of
damp
the
and
our
heat.
corrosion.
Also
Deteriorated
known
loss
as
of a metal as a result of the
when you
environmental
pass a damp
reactions.
sponge
So if
steadily
you
over
don't
the
have
coated
environment,
surface,
if you don't
the
have
water
the
is
metal,
drawn through the hole
then there's no
by the
corrosion.
reaction, and when it
And
touches the
also we
base
learned in
substrate,
school that the
it
ferrous
becomes
oxygen
corroded
moisture
to the
can
surface.
rust.
As the test
You
unit
learn
is
what ferrous
grounded to
oxide,
an
ferric
uncoated
oxide,
section of
ferric
the
oxide, we are
substrate
very
being
good at it in
examined.
past our
When the circuit is
exams.
complete, the unit alarms.
But do we really know what FeO is? Do we really know what Fe3O4 is?
The high voltage or holiday detection
So we get back to the
high
Eurocode.
voltage
Now
current
Eurocode is very nice when I
which is
looked at
passed
it.
over the coated
It
surface.
is
The
starting
voltage used
by
is dependent
classifying
on
the
the
environments.
strength and thickness of the
because
coating being
the
tested,
corrosion definition
and
is
or the test method
exposure,
standard with
environment
voltage.
and metal.
But typically,
So
the
if you
voltage
don't
should
talk
be
of the
higher
environment,
in areas where
there's
the
no
voltage
corrosion
is
to be
weak
spoken.
due to a flaw.
So I
There
think
is
you all
sufficient
are by heart
voltage
at
to break
this by
down the
now.
gap between the
EXO
coating and the
means
substrate.
no risk corrosion attack. So when you are
When this
doing
breakdown
a
occurs, the
building
current
in
flows
the
through the substrate and
say,
back into the
Aurelia,
unit by a grounding
you will
cable,
say the
setting off an
Eurocode
alarm to
EXO.
signal
I
the
don't know
flaw has been
how you are doing
detected.
it. And if you are doing in a
This
high
allows you to
chemical
detect
processing
faults
plant,
all the way down to
you
the
will say
substrate,
EXA.
as well as voids within the
Then the
coating.
contractor will have to understand
However,
what
it's
they have to
important
offer.
that the voltage isn't set too
You don't have to
high,
say
as
chemical
this could break down
all the
and
stuff.
damage
You
the
say it's
coating,
EXA.
causing
You
the
don't put
unit to
EXA.
alarm when there are no flaws.
And if you are
by
building
creating
a
flaws in the
building near
process.
the seaside,
Testing with bright
So
blue
it's a
sparks
chloride-induced
is a
corrosion.
sign the voltage
So
is
XC.
too high.
so you are using
So
these
you
little
can
words
the alarm only
which
triggers
gives a lot of
when set parameters
meaning to
when
that.
there is a flaw.
And you can design your
Triggering from the
durability,
charge
you can
to
design
the
your
present,
design
which builds up
the
the
structure
testing
to
process.
suit the environment.
Many high voltage detectors allow you
So
to adjust the
now we try to
sensitivity,
tell you,
ensuring reliable alarms.
maybe I don't know whether you know this.
The high voltage
Like the
method
Eurocode
comes in
2,
two versions.
We have our own
Continuous
D
DC
means the steel
and
meter,
pulse
capital
DC.
words. We have our own standards.
Continuous DC is
There is
where the
ISO
current
9223
is
and the ISO
constant
12944.
to test insulation coatings on
Now
conductive
ISO
substrates
Eurocode 2 is
up to
concrete.
7.5 millimeters.
ISO 9223 is for the galvanizing. Without
On
for the
Cometech has
galvanizing you
two
won't make
continuous
buildings.
DC detectors.
If it is a steel building, we have to follow the ISO
The power
12944.
supply is generated
So we
within
from
the
the
industry and sent
morning
to
to evening we are talking ISO 12944.
voltage cable.
But the issue is that now the present day buildings are having
The power
both
supply is
concrete
generated
and
with
steel.
a handle and connected
So,
back to the
structural
instrument by
engineers
the
will have
voltage
to buy
cable,
hard the ISO
resulting in a
12944
safer way
if
to
they are going
test
to
flaws.
keep their
The
promise.
Alcometer 266
So now this is
also
the same
has
thing we
an
put on the
volt
Excel sheet.
meter, also
The
known as a
XC,
G
the
meter,
corrosion induced by
ensuring the
corrosion,
test meter always
the
matches the
carbonation
chosen voltage.
is XC1, XC2, XC3.
There's also
so
an
there are
optional
different
two-stage
categories
safety
of
switch to
XCs.
avoid accidental
And the
switching.
chloride induced
The
corrosion
inbuilt
is
voltage
XC1, 2,
calculator
3.
that automatically
And you
sets
can,
the correct voltage
refer up
based on
your
your standard
stands.
and coating thickness value.
Similarly, the ISO
Pulse
9223
DC
is galvanizing.
is where the
Now
energy
you
is
look at there's going to be a galvanized
pulses.
steel
With
structure
each
coming at the
pulse
top of
having
the
more energy than an
cooler.
equivalent continuous
Now
DC
from
instrument.
top to that point
The
is
break in
concrete.
energy
Eurocode,
stops the
follow
coil
that.
from building up a
But
charge
from
on the
that point
surface,
is coming under
allowing you to set things for
9223.
flaws
So you
from
have to
damp,
know
dirty,
9223.
or slightly
So
conductive
9223
coatings.
also have
Using
specified
state-of-the-art
C1, C2, C3.
the Alcometer 280
C4, C5, CX.
holiday detector features coatings
Like your
of
exhaust.
25 millimeters.
Now there's a C1, C2. Now C1
Designed
is
to make
a
Pulse DC high
environment.
voltage
We are
detection
standing
safer,
here.
easier and more
It's a
reliable
very
than ever
dry
before. The
non-pollutant,
Alcometer
and
280
costly.
has an internal
So
G
CX is near the seaside, like your
plus a trailing voltage return cable. You don't
chloride-induced
have to connect to the
corrosion.
substrate, which is perfect for quickly
So,
testing large surfaces and
just trying
pipelines.
to
without
define
constantly
the
having to
industrial
click
and
on
the
click
sea
or
coastal
turn
exposure.
every
What
time
is
you
industrial
enter.
exposure?
There's also
It
the
is high
Alcometer
humidity,
280 grounding
ultraviolet
and
radiation,
grounding pin,
chemical
so
pollution.
ideal for testing.
And they say
ungrounded
the
parts.
increased acidic fall is
And
of sulfur
finally,
dioxide
the UV
more than
contact technique, such as the
250
Alcometer
micrograms
260,
per
which
square.
makes use of a fluorescent
In the
coating,
sea
which is
coastal,
applied to the surface.
why we call coastal environment,
Once the second
in
coat is
one
applied,
a
any
liter of rainwater,
fluorescence will be
there is
found
12
in the
milligrams
water,
of
revealing their location.
salt. So
Each
that is the
test
definition
is
is that if you
much
go
more
by
detailed
the
in the Alcometer pin
Wikipedia things you'll find.
detector series.
So the
Simply
what do you
follow
call
the
this?
link.
9223 galvanizing.
Or visit
So
Alcometer.
they categorize C1, C2, C3, C4, C5,
And
CX
please don't
from
forget
the
to subscribe
sulfur
to the
dioxide point of
channel
view.
to be notified when you
So
do it.
CX is very critical. The sulfur dioxide is 250 microgram over meter square. So no pollution like this building is C1, XO. So XO is C1. This standard has also the corrosion, the rates. I'm not going to go for that. Loss of metal. Loss of metal. Now, the gentleman asked us before the thing, okay, if it is a body galvanizing structure, how many years can it survive? This chart will show you very simply. CX means your seaside. Your thickness, generally 80 microns of galvanizing. 80. So you find it's only 5 years. This is from the Galvanizing Association of America in one of their brochures. So they are marketing it as 5 years. So this is hot dip galvanizing standards. So it has other connections with 14713 also, which is the zinc and aluminum. You have these zinc alum sheets. It has a different code called 14713. So now many people in this country feel if you have galvanized steel, no need for painting. Now that is a misconception. The Euro code, maybe not saying it, but the 9223 galvanized people are telling you. Now they will say C1, C2, C3, no need to paint it. But from C4, C5, you have to paint it. We will show you why you have to paint it. So now why we have to paint it? This is a cross section of the galvanizing. As you see, you see the base T, then gamma layer, then delta layer, zeta layer, eta layer has a 100% zinc. Now that is the DFT 80 microns or 250, whatever the thickness you build on. Now we know the ferrous is always anodic. We know the zinc is always anodic. So we have a combined fire put together. Because anode always sacrifice in front of the cathode. So this is the Sakrita strain here. So anode is here, zinc, anodic. Minus T is cathode. And you find the gold is coming under non-corrosion. Now this is how the galvanizing is done. You take a steel profile, put it in the caustic cleaning, then water rinsing, acid pickling, water rinsing, fluxing, and dip it into a 450 degrees centigrade hot dip zinc bar. And you get 80 microns or whatever the thickness you are asking for. Now when good people go to the Lanka transformers, they will give you a quotation and say, okay, we are doing by BSc and ISO 1461, blah blah, it's all given there. But if you don't know your Euro code, if you don't know your 9223, you don't know what they are talking about. They are telling here, C1, C2. This is good for only the inside the building and rural areas. They don't give any guarantee for the C5, CX. But if you don't know what C1, C2 is, we say galvanizing is good for any part of the country. So it's important that the young structural engineers get into this fast, because otherwise they are going to face some made a disaster. And also when you try to apply paint on the GI butter, you know your gates have GI butter, the paint peel off. The paint peel off. So that is one more problem. When the paint peel off, the zinc will catch oxygen and make zinc oxide, the white dust. So zinc also corrodes. In addition to being sacrificed due to the... Now this, we want to show you what the dockyard does with the ships. Now this is a ship's hull, a rudder. You can see there are anodes. Zinc anodes. Can you show zinc anodes? Robert? Yeah. Now this is a zinc anode. Fresh one. Now after 2 years, this is your zinc anode. This is sacrification. So what happens? We learned it in school. The electrode 1, electrode 2, cathode reduction positive, all this stuff. And we know after the current start running, electrons start running, your anode is going to sacrifice. Now this is another one, it's a heavy stuff I sent you. This is a corrosion, this is sacrification. So steel hull, to protect the steel hull, you sacrifice the anode. So every 2-3 years you remove the sacrificed anode and fix a new one. So that's how the steel is checked. So this is sacrificed anode. So zinc in the galvanized is prone for sacrification if you get to the correct environment. So you see the zinc being corroded. Now this particular Yakutavati is from Portland. Now they put the GI bucket. They all these wind turbine companies. I took the photograph from there. After 1 year, zinc layer was sacrificed. Then the corrosion started. Because people thought zinc is final, but this is CX. That is your CX. So don't keep a galvanized alone in a CX environment. This is the GI, the paint will peel off. This is zinc staining up, galvanizing staining up. And now this, if you look at this photograph, some smart fellow, he painted all the holes, but those GI brackets, he didn't paint. He thought, no, this, nothing will happen. This, after 2 weeks after he took the photograph, the whole thing fall off. Because zinc has to be painted. Now this is a sea purlin. You know, you use a sea purlin. It looks very thick. But I put the ergometer onto that. The zinc layer is only 29 microns. 29 microns. So if you put the sea purlin in the Gold Face Hotel, before 6 months, the whole thing will collapse. Now you take the zinc alum sheet. Now zinc alum sheet, you take cross section. You have a zinc base, then there is an intermetallic alloy layer, then zinc alum coating, then the clear resin coating. Clear resin coating is just a eyewash. So now the base metal steel is ferrous cathodic. The zinc alum is anodic. So you fix it in Norelia, no problem. You fix it in Martale, no problem. But you fix it in Gold Face, CX, you are in heavy trouble. Now, one thing, this is a warranty certificate of a very reputed zinc alum roofing sheet company. I removed the names. Now they say Sheds and Garages warranty zinc alum steel 15 years. You just go to the internet, put Sheds and Garages warranty zinc alum, you will find this PDF. I removed the unnecessary parts. Now we say warranty 15 years, so why worry? But from this warranty subject to, they are trying to exclude. Now the 3, installation greater than 1 kilometer from marine industrial environment. CX. Under CX, 0 warranty. That's what the people say. But sometimes you will go and ask the contractor, give a 15-year warranty for this zinc aluminum sheet in the CX. It's a very unreasonable request. If you know your ISO, Euro code, you will never request for the warranty. Because you can't request, the manufacturer doesn't give you his warranty. He's excluding the 1 kilometer from the seaside. Because it's sea breeze. And if you fix something in the petroleum corporation, you find those fumes are going up, the sulfur dioxide is burning, sulfuric acid will happen, and acid rain will fall. Acid rain is electrolyte. So it will corrode it will sacrifice the zinc alloy. Then after that the base metal will corrode. So you cannot ask a warranty from the zinc alloy sheet unless you give a heavy thickness. So due to the competitiveness, they don't give the heavy thickness, they give the low thickness and give a 15-year warranty. After 1 year, nobody can find that contract. That is the problem. So having stated, now this is fitted with bolts and nuts, corrosion. That is nothing but AC and B. We talk about it, anode, cathode, metallic pathway, electrolyte. We learned in school. Now this is a CUI. It's a very dangerous stuff. If you are doing a hotel or some factory, there are certain pipes to be insulated. So what you do is, you don't paint inside, you just insulate it. And be happy because you can't see the corrosion now. It's insulated. You have put the clothing and covering the corrosion. Now after 6 years, you don't know that the inside is corroded. Now this is the CUI cycle. So you have this inside that hot air is going, hot product. And the condensed water will get into the bottom and start the corrosion. So it's one of the major problems everybody is facing. Now stainless steel. I respect the gentleman. They say 316 corrodes. I like that. It's maybe correct. But the issue is, according to the science, 316 should stain. Because this is called stainless steel, not stain impossible steel. Yeah, now if they stain impossible steel, that means it won't never stain. But this is stainless, it will stainless. So that's the meaning of stainless, not still impossible. So what is happening? Now stainless steel, if you take, there is 16% chromium, 12% nickel, 2% manganese, that will add up to, my arithmetic is not very good, 30%. So 304 and 316, 304, 316, both are stainless steel. Both are having same chromium, same nickel, same manganese. But if you really analyze, your 316 has 3% molybdenum. So never put a 304 into the C side, CX. Always choose 316. Maybe there are different categories of 316 also, which I am not very educated among. But 316 shouldn't stain according to the molybdenum 3% chloride corrosion. So now we come to the ISO 12944, which is my side. I am a steel board. Now we are not Eurocode people, we are not 9223 galvanized people, we are paint people. Now paint people go by the 12944. So if you see, the same letters are happening. C3, C4, C5. I'll go to that quickly. C1, C2, C3, C4, C5I, C5M. So CX is C5M. C1 is XO. So same environment. Only I think they should all get together and put one legend. I think it will make things easy for everybody. So this is the chart. C1 is heated building. C2 is rural area. C3 means urban area. C4 means industrial area 1 kilometer away. C5 M means marine 1 kilometer within the coastal. C5I is industrial city 1 kilometer inside the industrial city. So you find for a industrial city or a sea coast, if you want to keep the durability 15 years, you have to apply 320 microns. Now that we are not telling, ISO is telling. So if you are trying to buy that paint, don't come and ask for paint, ask for 320 microns. Then you will be okay. So the paint is the thickness which you are going to achieve. Now there are 8 categories, C1, C2, C3, C4, C5, and I1 is fresh water, I2 is seawater, I3 is underground. Now we had a superb situation when we supplied paints for the what do you call this water board project at Walaveganga. This side of the Walaveganga, the seawater came and hit the barrage. This side of the barrage was fresh water. Certain parts were embedded underground. Certain parts were with the sea breeze direct. The river side was no sea breeze. So we had IN1, IN2, IN3, C5N. In one structure we had 4 or 5 environmental conditions. But of course we couldn't change the DFT to suit we put one DFT forward. So the next question, the ISO telling, I don't know whether Europol is telling you, sir, the durability. The ISO 12945 is super. They say, do you want 2 to 5 years durability, 5 to 15 years durability, or 15 years or more? So if you are coming to buy some paint, don't come and ask me for the liter price. You tell me, please give me a paint system, ISO 12944, C5N environment, durability 15 years, I can give the quotation. Because you have to go by the ISO if you want to stop the corrosion. If you want just to buy the paint, don't come to us. Because it's a waste of money. So now if you see this building, it says ISO 12944, durability high, exposure C4. So we know the thickness is 280 microns. It said 280 microns. C4. So thickness is very simple in that. So now we come to the corrosion side. Now we talked about the ferrous oxide, ferric oxide, ferrous oxide. I'm going a little fast now. Now before we started, people asked questions. What causes corrosion at heat affected zones? What causes corrosion at stress points? What causes corrosion buried steel? What is the corrosion prone area? That is well seamed like that. To answer that question, you have 2 theories. One is the ACME theory, other one is the pH connection. Without the pH connection, you cannot solve it, like understand it. So yeah, we'll talk about the 2.
This animation illustrates current flow in a corrosion cell. Corrosion occurs at the anode, with no corrosion at the cathode. Although the animation illustrates 2 pieces of metal, the corrosion process can occur on a single piece of metal also.
Galvanized steel. That connection is the metallic pathway. If the salt comes and deposits on that surface, you have a electron running. So the sacrification is on the zinc side. Now if you take a yard piece, you take a hammer and hammer it hard. That point becomes renal, minus, negative. So in one steel plate you have a negative and a positive. And when the salt is deposited or you put it under the ground, you have a pitted steel. That's the reason. Pitted steel is nothing but you have a minus and a positive and negative in that particular plate, and an electrolyte came and hammered on it. So it's easy to explain. Now this is also nice. Like we call the corrosion prone areas. They say never put a steel part like this because it's what is stagnating. Now the building is C3, let's assume, but that point is IM1. It's a water stagnating point. So if you are applying 320 microns, inside you have to apply 500 microns. If you don't consider that exposure condition, miniature exposure condition, then you will never solve the problem. And also my friend said, is very important. You will have dengue Madru also there. So as structural engineers, when you are doing this, try to avoid corrosion and the dengue problem. Because if the water, the problem for the country also, for social responsibility. So now this is a galvanized gold. Now the zinc is getting sacrificed. Very soon the zinc is already sacrificed, corrosion starts. So like the minister, the ferrous is the minister. The galvanized is the bodyguard. So you have to protect the bodyguard. Because you hit the bodyguard, the next guy is the minister is going to be home. So galvanized always have to be protected. So now we come to this steel manufacturing. You have this iron ore. You get it to a blast furnace and make billets. Iron ore is in a low energy state. So you take it and put it in a 1900 degree centigrade blast furnace and make it steel. So you bring it to a high energy point. So the corrosion has another concept called corrosion is getting the high energy into a low energy. So to stop the corrosion, you have to somehow stop the energy going down. The pH connection. The seawater has a pH of 7.5 to 8.4. Now this is your, everybody knows this pH acidic, neutral, alkaline. But the pH connection for the corrosion is pH 1 to 8 is acidic, highly corrosive. pH 8-9 is low corrosive. pH 9-13 is no corrosive. Passivation. So if you can maintain your pH value at 11 to 13 or 14 or whatever, you will never corrode the steel. That's what it says. No corrosion possible at 11, 12, 13, 14. Now to explain, I get back to the Eurocode 2. We talk about XC1, XC2, XC3, XC4, the carbonation corrosion, induced corrosion. Then the chloride induced corrosion. Now this is falling. You have the steel bar, it got corroded, got bloated, the piece fall off. So the steel is exposed now. Now this toe bar. I think some people have come to this earlier, so they should answer this question. Now this is a new toe bar. Can you see corrosion? The long one, which is the better one? Which is the better one? Don't answer, just keep it in your mind. I have given you two toe bars. So now, coming back to this concrete corrosion, the four, what Professor Priyanka has told us that day was carbonation, chloride penetration, oxygen diffusion, moisture penetration. That's what I learned from him. Now, how can the carbonation induce corrosion? Now we have to explain that. Now concrete, as you all know, this steel reinforcement and everything. So in the carbonation, there are two types of carbonation. One is the early age carbonation, where the concrete is mixed and poured, the carbonation occurs. Then after that, after curing, you have weathering carbonation. So this is the early age carbonation. And it is connected to the RH also. Now carbonation, if you see, at 100% RH, very less carbonation. At 55% is very bad carbonation. Because at RH 100, there is moisture ingress. The carbon dioxide cannot get into the concrete. So that's the relation there. So this is the four carbon dioxide carbonation, chloride penetration, oxygen diffusion, moisture diffusion. So you have a half-inch cover deck. So this is the same picture in a different way. What all this thing is telling is, you have inside the concrete, the carbon dioxide will make carbonic acid. Weak carbonic acid. All from the internet. I didn't, not my subject. Now what happens? Now this is the today's concreted building. Now this is the output.
As rock explodes and the raw materials of steel are tossed from the earth, the rock is taconite, and the prize inside is crude iron ore. We get at it by grinding the rock to powder and separating the ore with powerful methods. Then we form and heat the ore into marble-sized pellets that will later be converted to iron. From bituminous coal, we create coke to fuel the iron-making process. We crush the coal, seal it in airtight ovens, bake for 12 to 16 hours, and remove it from the oven as solid carbon fuel. The fuel and pellets come together in the blast furnace, where we add just enough limestone to remove impurities. From below, a continuous blast of superheated air combusts the coke, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine lathes that ride on rails to the basic oxygen shop, where iron will be turned into steel. In this fast-paced sequence, up to 250 tons of steel can be made to order in less than 35 minutes. We begin the steel-making process by dumping recycled steel scrap into the basic oxygen furnace and adding hot iron. Sparks steal the show when high-purity oxygen is blown into the mix at supersonic speeds and molten iron becomes molten steel. Now we're ready to create the custom blends that make steel the most widely used metal on the planet. In fact, we produce over 1,500 different chemistries to meet customer demand for cutting-edge, value-added steel. Look for another show of sparks as we tap molten steel from the Bop vessel into a ladle. Then, for most of our steels, it's on to the vacuum degasser, where they are made highly formable. The focus then shifts to forming and finishing, which determine even more of the steel's characteristics. The first step in this sequence is to position the ladle above a massive tundish or funnel that feeds a continuous caster containing molds that shape the steel. The molten steel, now at 3,000 degrees Fahrenheit, is channeled from ladle to tundish to caster, where it cools to a red-hot solid. The shape of the mold determines the shape of the semi-finished products that come out of the caster. And since most U.S. steel plants make sheet products, most of our casters output slabs, typically 8 to 9 inches thick and 3 to 5 feet wide. As they exit the caster, slabs are cut into sections up to 40 feet long and stacked to await further processing. Then it's on to the hot strip mill.
Stay there, 1,200 degrees centigrade, and will come out hot, red hot. But now the steel is soft. You can hold it. And they use
Das sind
water.
Stahlblöcke. Die sind ganz schön schwer.
Cooling, because you have
Ein
to
so ein Stahlblock
1,100
wiegt
degrees
ungefähr so viel
centigrade.
wie
Hot
eine
temperature
Beton.
is 1,100 degrees centigrade.
Diese Stahlblöcke werden erstmal hier abgelegt.
They use water to cooling. Great job.
Und dann werden die Stahlblöcke weiter transportiert über diese Rollen.
Big stands, rollers. And
Es
the
geht zu
shape is
einem
like that.
großen
The end
Ofen.
product will be there. If you want to go bar, you
Da kommen die Stahlblöcke rein.
on this and pull it, roll it.
Und in dem Ofen werden sie heiß gemacht.
And now it goes into that wheel stand. And
1200 Grad Celsius heißt.
shape.
Wenn die Stahlblöcke richtig rot glühen, dann kommen sie am anderen Ende wieder raus. Und auf diesem Stahlblock kann man so schwarze Punkte sehen. Die müssen erstmal abgemacht werden. Das passiert direkt neben dem Ofen.
And goes to the
Mit
it goes to the finished goods stores. Now these are finished goods stores. Now the steel is brand new. I sent you a TOPA and asked you how much corrosion can you see? many people in this country say no corrosion. Malakat name aate. The brown one, 100% corrosion. That itself is a problem for us. Because they are going to apply paint on this. Because no corrosion. No corrosion means you can apply paint. But the issue is, when the manufacturing is done, you saw the water being splashed. You saw the oxygen coming in. It's done in the normal atmosphere. So at that temperature, 1100 reduces to 700 degree. The recrystallization temperature is 723 microns centigrade. Sorry. That high from 700 degrees centigrade, the corrosion takes place. So when the steel comes to the yard, it is 100% corroded. This is 100% corroded. Because your steel ferrous is Riddhi part. This is not Riddhi part. So this is 100% corroded. You need to remove the Riddhi, nil markade, and bring it to the silver before application of my paint. That is why the sandblasting comes in. But many people in this country think this is not corrosion. This name is mill scale. Mill means mold, scale means korpotta. Korpotta means difficult to remove. Korpotta is difficult, no? Korpotta. So this is mill scale. Now what happens? The new steel is 100% corroded. Why? When the temperature is coming like that, red hot, at 700 degrees centigrade, corrosion will take place. Now how the corrosion will take place? At 700 degrees centigrade, there will be 85% ferrous oxide, 14% ferric oxide, ferrosulfuric oxide, and 1% ferric oxide. Now we learn ferric oxide, ferrosulfuric oxide, ferrous oxide, everything we learn. But our school did teach us the color of the malakadi. For us, malakadi is blue. Any other thing is jagada. Now this blue color is Fe3O4, ferrosulfuric oxide. So when it comes to the 500 degrees centigrade, it is totally corroded. The blue rust, mill scale, korpotu malakadi. You can't remove that. Now, what we do in dockyard, we take the blue scale and do sandblasting and get the silver out. That's what our job. ISO 12944 says SA 2.5 sandblasting. Because we have to take the blue off. Now people think you can remove it by grinder. Now see, that is the blue new yakada. Now you take a grinder wheel. Can you stop for a minute, Mr. Arun? There are two problems. One is our education system doesn't teach us blue is corrosion. So all the painters, as I told you, structural engineers are there, subcontractors, main contractors are there, subcontractors are there, painters are there. Now they don't have education also. They don't know ferrosulfuric oxide. They don't know ferric oxide also. So what they think is make a malakadi nahi mattu. Make a sudhakara don't nahi. Make a roll, grind karna. Grind karna do it. And make a malakadi nahi. So how to educate our Sri Lankan people, because the people who jump from the education system to the painting yard due to economic problems, now if they are not educated with this nil malakadi, we have a serious problem. You good people are putting up UOQs and structures and things, but finally the paint pass unnahe, he dictated the terms. Now you see, now he just grinded it, and you see that nothing happened. It's only polishing of the blue. It's only polishing of the blue. the Riddhi part didn't come out. So a Sri Lankan contractor will apply my marine paint on the Neil Malakadi. Who is going to track him? So what we do is, when they come to buy my paint, we say no training, no selling. So we educate the guy that Neil Malakadi is the Malakadi. Then you sell the paint, then at least something is better than nothing. See, there's no Malakadi. Now he does a little, this is a video from the YouTube. Now he takes the Neil Malakadi, grinding mill and Galvana value of Neil Malakadi, he put it onto the hydrochloric acid, 30% concentrate. 30% concentrate. 15 minutes into power. Then grind again. Now he takes it out at the 15th minute, and you will see the grinder couldn't take off the mill scale. Acid takes it off within the finger. The mill scale removes with the finger now. Because 15 minutes in muriatic acid or hydrochloric acid 30% concentrate. He takes put in the water, take a cotton waste, and now no need of grinders. The sandpaper takes the mill scale off. Okay, acid has removed the hardness. Now this is the education status of our country, who are going to pay into your structures. So if you don't educate, because there is no NVQ for this also, painting. For welding you have NVQs. But the corrosion there is no NVQs qualification. Because I think nobody knows the seriousness of this. This blue scale, this is how the Tobas are manufactured, mill scale is happening. The new Yakada, 100% corroded. If I put my Ergometer paint thickness gauge onto the mill scale, there is 16 microns of Malakada. We have to remove the 16 micron before applying paint. Now this Riddhi is the Yakada. This is the steel. And this is the Malakada. The unknown Malakada. So this one, if somebody saw it before the beginning of this section, is a 40% corroded. It is 100% corroded. 40% brown rust, ferrous oxide, ferrosyluric oxide is 60%. The hard corrosion. Now see, if you look at the chance, they only clean the brown part. The nil part knows that there are. So unless we train our customers by force, they don't know what they don't know. So we call it FATO4 is mill scale. So this is a 100% corroded plate, 100% corroded plate. So the international corrosion people have classified the Malakadi into 4 categories. The mill scale is called the A grade rust. It's in your docket. It's in your docket. What they do is they take the Yakade, put it out to the weathering, keep it for some time. Can you show weathering? Start weathering. Is the time up, sir? Is the time up? A little more. And now say this guy. Now this guy is putting water, that there's a blue colored steel. Now this is the mill scale, A grade rust. Now this guy puts the water and bring A grade rust to the B grade rust. If you put more water, it becomes C grade rust. If you keep it for 6 months, it is a D, pitted steel. Harry. So there are 4 grades of steel corroded. A grade, B grade, C grade, D grade. So we never use A grade rust for corrosion cleaning. Now this is the ISO book, which we copied this information. This should be in every CCB everywhere. This book is a very important book. The rough grades of steel. So they plastic, let's say 2.5. But of course, Professor Priyan Dayas knows when we did this center point building, they wanted to remove the wall, that mildew, and they were doing the night pouring and doing the so dust is a problem. So you can't use, if it is steel, you can use some grinding machine. That's why in that dockyard presentation there was called vapor blasting machine. Now vapor blasting machine is a thing like this. It has a water container, it has a sand pot, and it creates vaporized garnets, and when you blast, there is no dust. You can do it in the middle of city, clean anything in the middle of city without getting environmental problems. So this is say 2.5. Look at this. This is A grade rust, this is B grade rust, this is C grade rust. So now when we see the academy hereafter, always radio rust, because we know A is the worst for our cleaning process. Because if you sandblast this, it takes 10 tons of sand. If you sandblast this, you will need 2 tons of sand. As a contractor, you want to have less tons of sand because it will reduce the cost. So what you do is you take the plate, put it out, weather it, bring the A grade rust to the B, C, then blast it. But the issue is, when you go to do that, with due respect to the engineers, they say, don't put it out. They don't allow us to put it out. It will corrode. This is 100% corroded, this is 100% corroded. There is no extra corrosion. So you have to weather it. That's what the video showed. So this is mill scale. And the worst part is, ferrosulfuric oxide mill scale is cathodic to steel. Now this is the mill scale, this is cathode. Now the issue is, this is cathode, this is anode. So when you have the salt or water coming, it will go here, and what will sacrifice is the yakade. Yakade missing sadhanla the malakade missing yakade vinasha karuna. How do you do it? Bulk you. So this is now when you go for the toba, you say, but both are corroded. But that's a good thing. In your concrete structures, your pH value is 11-13, so it won't harm. There's a little leniency on that. So if you want to have no corrosion, build the structure with gold or platinum, there's no corrosion. And give me a percentage also, please. So these are the less corrosive selection. Magnesium, zinc is high corrosion, gold is less corrosion. So they are coming up now, they come to the end. So you want to stop the corrosion, modify the environment. From the C5X, if you can bring to XO, no corrosion. Use the correct metal, not 316, sorry, don't use 304 in the chloride induced areas, use 316. Cathodic protection, anode cathode. Corrosion inhibitors, in a boiler inside you put corrosion inhibitors. Coating system, plating, and finally the knowledge. Now this is the father of corrosion, Dr. U.R. Evans. He wrote a book in 1924, published the book Corrosion of Metals. So we respect him a lot. So this corrosion is his, and Ratan Tata is the Yakada manufacturer. He says none can destroy iron, but his own rust can. But how, from where did he learn this? Nothing is permanent. So this is your recorded history. How the corrosions. Yakade visin sadhanla the malakade visin yakade vinashakuru labi. How the can budu maase. Vasant Dada Saise Kisala. Api kena father of corrosion is Evans Kira. Nama pada desi hadri atau apa?